This lesson is about C-style arrays and strings. There's also an STL class called array and an STL class called string, so this can lead to some confusion. This lesson is not about the STL classes. I'll cover those later in the STL chapter. C arrays and C strings are fundamental types in C++ and are very different than their corresponding STL classes. This lesson is about the C array and C string fundamental types. An array is a fixed-size container for elements with a common type. This is a definition for an array of integers with room for 5 values. At this point, the array is uninitialized, so each of the 5 integer values are undefined. Arrays are indexed with integer values. The first element is always numbered 0. So an array with a size of 5 will have elements numbered 0 through 4. The value in the square brackets is the index. This means that we're assigning a value to the element at index 0. This assigns the value 1 to the first element of the array. Array elements can also be accessed as if the array were a pointer. This statement has exactly the same effect as the previous statement. This is a very common practice, so you'll need to recognize it when you see it. This defines an integer pointer and assigns the address of the array to the pointer. Notice that you don't need the address of operator to get an array's address. This is because an array may be accessed as if it were a pointer. This assigns the value 2 to the first element of the array. Because the pointer was assigned to the array, it is pointing to the first element. You can increment the pointer, and it will point to the second element. In C++, pointers are strongly typed, so they know the size of what they point to. So when you increment a pointer, it always increments by the size of the object it's defined with. So this assigns the value 3 to the second element of the array. This is another common technique in C++. Here we're incrementing a pointer and using it at the same time. It's just a shortcut for the separate increment and assignment of the previous two statements. You may also initialize an array using an initializer list. This assigns the values 1, 2, 3, 4, and 5 to the 5 elements in the array. This is a new feature in C++ 11, so it may not work on older compilers. A C string is a special case of an array. Again, this is different than the STL string class. The C string is a fundamental type. To illustrate, let's look at an example. Here in Xcode, I've opened a working copy of working.cpp. In fact, a string is just a special case of an array of characters. So if we define a string like this, then we can print it with a printf statement. The %s in the format string for printf means that it's a string that we're printing, and it will put the string there in our output. So when I go ahead and build and run, it says string is string. So in C++, a C string is simply an array of characters terminated with a 0. This is sometimes called a null-terminated string. So you can access the individual characters just as you would in an array. Now, I could also define this string like this and get exactly the same result. This is a C string, so a string of characters inside of quotes is treated just like an array. It actually is an array of those characters terminated with a 0. And so when I build and run this, we get exactly the same result. Now you can access these individual characters in this array just as you would in any array. So if I use a for loop here, and we'll learn more about for loops a little bit later here, but I can say for int I equals 0, s sub I, so I'm subscripting the array. I'm looking at the individual element of the array that's indexed by the I integer variable, and we'll increment I. Again, you'll get the details of the for loop a little bit later. Some of these concepts are just so circular that we have to use some of them before we really get into the details of them, but we'll get loops a little bit later in this chapter. But for now, understand that we're simply looping through the array and looking at each individual character. So when I print this, I'm going to have to change this to look at a character instead. I'll say char is %c, and I don't want s anymore. I want s sub I, and so that will show us the character that's at the index of the integer I. And I go and run this, and we see we get each of the individual characters out of that array of characters because the string is actually just an array of characters. You can also use a pointer instead of an integer to look at the individual elements of the array. So I can say char pointer C because a string is an array of characters. I'll say CP for a C pointer, and I'll initialize it with the first element of the array. Remember, the array by itself can be used as if it were a pointer to the first element of the array. And then while what's pointed at by CP is not equal to 0, and so this is a shortcut for that, and then increment the pointer like this. And now I can simply look at what's pointed at by the pointer, and we get exactly the same result again. You can also use a range-based loop, which is a new construct in C++ 11, to look at the array. And so we'll just, inside the for, we'll simply say char C and a colon and S. And now we just want to look at C like that. And I can build and run, and we get exactly the same result, but you'll notice that there's an extra element down here, which is the null, because the range-based for loop is actually looking at the entire array. It's not treating that null as if the end, it's simply looking at the size of the array. So I can break out of the loop like this, and again, we'll learn about break when we learn about loops a little bit later, but that simply breaks out of the loop when it sees the null terminator at the end of the string. So I run this, and we have our result, string. So the combination of C arrays and pointers is really powerful and really common in C++. An array is a structure of variables of the same type stored contiguously and indexed by an integer value. Because the array is guaranteed to be stored contiguously, it's also easy to iterate with pointers, and C++ syntax lends itself well to this usage. So we'll go ahead and delete our working copy and run clean to reset the workspace for the next lesson.